Go. Great. Thanks very much, Margaret. And thank you again for the invitation to be here tonight and for people's interest. Thank you for all for joining us here. Hopefully everyone's staying nice and cool, or as much so as possible. I had to turn off our little floor unit AC so that you could hear this. So we're going to see if I make it through this. That's the hope. So I'm going to pull up some slides here. Hopefully those are coming through all right there. Looking all right? Thumbs up or yep, perfect. Okay, great. So I'm a postdoc at University of Toronto. I work in a forest health lab. My projects broadly over the last several years have dealt with biological invasion, and this is something that we deal with more and more often as the world becomes an increasingly globalized place. So as humans move about, we move a lot of material with us, and this creates various sources of ecological novelty. So you have new species there, but those new species don't keep to themselves. They interact with other species. So you get these novel ecological interactions, and that can really pose some interesting and challenging questions for how do we do everything from conservation to gardening. My main projects these days don't actually deal with worms. My main work is with weedy plant species. So I deal with introduced Phragmites, which is a wetland grass, and garlic mustard, which is an understory forb, and how to try and manage these populations using biological controls, very host-specific natural enemies, in these cases stem-boring moths and weevils. So this is what I'm actually sort of paid to do in general. But my background in terms of doctoral work and master's work has been looking at non-native earthworms. So it's an area of research that I try and stay active in as much as possible. So most earthworms in Canada that we have are non-native species, and historically this has meant primarily from Europe. And this isn't just happening in Canada, this is part of a global invasion process. So we have non-native earthworms spreading to every continent of the world except for Antarctica. We did have native North American earthworms, but these were mostly wiped out by the glass glaciation. So as those glaciers retreated, you have soils left behind, now earthworm free. It's an open ecological niche for earthworms from elsewhere to move into slowly over the subsequent thousands of years. As with so many invasive species, the earthworm invasion is very much a human-assisted process. So we're sort of the main force that drives this. And there are a number of different mechanics that can move worms around. The important thing to remember with earthworm invasion is that it's not just earthworms themselves, it's their cocoons. So if you look in the sort of top right there, those are a number of actually jumping worm cocoons. They're just little small nondescript spheres that can be very easily overlooked in soil or in a potted plant or something like that. So, even if you are looking for them, it can be very easy to miss. So cocoons, worms, or a mix can move about in ship ballast. Was one of the big historical ways that they probably get here, is a ship from Europe drops its sort of physical ballast onto the soil. There's worms in there, they spread out from there. Material can also move around in horticultural plants, mulch, soil, and so on, and we'll get into more of that later. With other types of worm, bait disposal has been a big one, especially in rural areas. You have extra fishing bait, you dump it in the woods when you're done, that can become a new population. But really anything that moves material around, soils around, so road work, can carry material many, many kilometers at a time. Even sort of the treads of vehicles and shoes can carry cocoons that are mixed up in the mud there. So this process, sort of, if we think of this on the map and we think about a worm, they don't move particularly quickly on their own. So again, this is where sort of humans come into it. So if you have a population of earthworms that lives in a certain area and you have humans jump in and move that material potentially over very long distances. So again, maybe we're shipping horticultural plants to different parts of the country or to different countries. Those become new nodes of populations that are now in those areas. Over time, those populations spread out very slowly on their own to make sort of that local population. And then, of course, this process can be replicated over and over. So each node can become a new source of invasion as well. So this is what we would call a jump dispersal mode of dispersal, where they're sort of moving large distances with our help and then slowly spreading out from there on their own. Why do we care about this? Earthworms are very influential ecologically. They are what we call ecosystem engineers. So when they arrive in a soil, they will physically change it, and they have a disproportionate effect on the ecosystems that they live in. One of the big sort of things that they do is they will dramatically alter the soil profile, so the distribution of materials and textures that go below ground. And soil is, of course, the foundation for all the vegetation and really the whole ecosystem. So by changing the soil, you can have cascading effects on the organisms that live in that soil, including over and understory vegetation and how that all comes together to function. So they really are a game changer. The question that we would get a lot, and it's an important question, is kind of broadly, are earthworms good or bad then? Because for a very long time, we've had and still have this narrative of earthworms being indicators of a healthy soil. It's what you want to see in your garden. You're trying to encourage them. It's a sign that you're doing things right. And then we have this mixed messaging of earthworms as this major problem. So what's going on here? Um, and the really big thing is it depends. And one of the big things it depends on is what type of system we are talking about. So there definitely are situations where any kind of earthworm is broadly what we might call a good thing. So for example, in a garden or in an agricultural production system, what earthworms bring as decomposers, making nutrients available, aerating the soil, bioturbating, essentially tilling the soil for us, is all very useful. And it can create productive gardens in agriculture, and that's why they are desirable and encouraged. However, there can also be situations where they are what we would call a bad thing. This tends to be more natural or semi-natural areas such as forests or grasslands. We work in forests a lot, so that's sort of what we're using here. But broadly, these systems are not adapted to earthworm conditions. So a garden, a field is sort of, it's an artificial system. These more natural ecosystems are not kind of a use to this essentially. So when you have this kind of rapid decomposition of organic matter at the soil surface that would normally sit there for a much longer time, break down far more slowly, this can expose the soil, leaving big bare patches. This means that seedlings can struggle because they're exposed to herbivory or they dry out. And while this process does create nutrients that are then available for plants, if those plants aren't able to take those up in a timely fashion and make use of them, those nutrients will then either be lost, leached away, or potentially taken up by some sort of invasive species, for example, that's very weedy and fast growing and able to make use of those nutrients when the natural sort of biodiversity isn't. Depending on the species, if they're very active at the surface of the soil, the alteration of the soil texture can also create these really granular particles that can be eroded away. So if you're dealing with soil erosion issues or you're on a steep slope, that can become a problem as well. And so one of the challenges is we have these situations where it's kind of a good thing, situations where it's kind of a bad thing, but they don't stay contained to one or the other. And often they end up in the sort of bad circumstances because they came from where we want them. So they spread out of a garden on their own very slowly, or we dump materials or cocoons or any of the various other dispersal vectors that we talked about previously. Now, when we've talked about earthworms up to this point, what we've generally been dealing with is what we would call now the first wave of earthworm invasion, but there is now a second, as you're probably aware of. The first wave of invasion is largely looking at species coming over from Europe, and this can date back to the 15 or 1600s and is still going on to this day. So as long as you have material moving back and forth, there's the potential for reintroduction of the same species or just more of that species. But we're now seeing this second wave of invasion. This deals with species that are coming over instead from Asia, East and Southeast Asia, and is much more recent. We don't have great records for a lot of this, but in the US, this sort of tends to pick up around the mid 20th century and is becoming more common as time goes by. We're talking, and I will refer to them today as jumping worms, but really what we're talking about are multiple species. So jumping worms broadly refers to 16 species of ferretomoid earthworms from 12 different genera from different parts of Asia. You'll also notice they go by many different common names. They can be called jumping worms, which is what we tend to use, but you'll also see them referred to as snake worms, crazy worms, jumpers, all sorts of different things. But these are the same kind of group of species. How then do these differ from European earthworms? Is sort of a worm not a worm? Unlike a lot of European earthworms that live in sort of different parts of the soil profile, jumping worms tend to restrict themselves to the top 5 to 10 centimeters of the soil profile. So they're fairly shallow burrowing. You find them close to the soil where they're feeding on organic matter that's breaking down. They tend to be parthenogenetic, which means that they can reproduce on their own, which makes them very adept at forming new populations. So even if you get a small number of individuals introduced into an area, that can become a new population very quickly. They have an annual life cycle, which is a bit odd because most of the European species don't. Our European species will live several years and have various strategies for overwintering. Jumping worms, in contrast, will hatch in the spring, grow up, from their perspective, ideally reproduce, and then die. And they will then overwinter as cocoons, which hatch the next spring. So they have this very sort of concentrated, fast, quick-moving life cycle. And that sort of typifies their life cycle and their impacts overall. So it's very sort of rapid and very concentrated. So they can have these dramatic impacts on soil structure and function that come about very, very quickly. One of the other explanations for why their effects differ from those of European earthworms, not necessarily in the type of effects that they have, but more the degree, the intensity of that effect, is that when we have large European earthworms like a dewworm or nightcrawler, which we see pictured here, which is our largest species, they tend to occur at very low density. So you might just get a couple per square meter of soil. You get high density worms where you get hundreds per square meter of soil, but they tend to be very small. Jumping worms sort of deviate from this pattern by being both large-bodied and occurring at fairly high population densities. And it's sort of the combination of a large number of large worms that gives them this substantial impact per unit area of soil. So where did they sort of come from? As was flagged before for earthworms in general, jumping worms tend to be strongly associated with the horticultural trade. We'll touch on this a little bit more later, but they tend to be, or we suspect, that they're transported mostly in mulch, in soil, various potted plants, and so on. And that's kind of how they came over and then how they move between different areas. This has been primarily an American problem up until this point. At sort of around 2021, they were found in 38 US states, especially in this sort of along the eastern seaboard there. In Canada, there had been some isolated connections from the Ojibwe Prairie near Windsor, Ontario, so right near the border with the US back in 2014. And these were made by earthworm taxonomist John Reynolds, who literally wrote the book on earthworm taxonomy in Ontario here and is a real expert on this. So he found a few, but they were pretty isolated collections. So this changed last summer. So in August 2021, I was working on these biocontrol projects. We were doing all of this, and these reports started to come to us from members of the Master Gardeners of Ontario of these kind of unusual earthworms that people were seeing. And this was coming mostly from their gardens, just sort of in their private residences. So I went out to some of these locations, did some digging, did some earthworm extraction, some collections, and sure enough, that was the first time that I sort of witnessed firsthand jumping worms for myself. So we did some identifications on these, depending on sort of the species. To get them down to species level of identity, we usually have to dissect them, but you can sort of tell broadly they're a jumping worm just by looking at them. We wrote this up in a paper that basically can be summarized as, well, we've got them here now. This is a figure pulled from that paper showing those different observations of the different species. We had 4 different species across our multiple samples. They're listed here. Most of these are fairly common species in the US, so there wasn't anything particularly surprising in that regard. These are kind of some of the ones that we would expect to show up first. And you'll note they tend to be concentrated around Toronto, Hamilton, and Windsor there on the map. So we now knew all of a sudden the summer was kind of coming to an end. We had this first real evidence of jumping worms substantively being present in Ontario. The question was, what do we do with this next? There are very few people who actually work with earthworm ecology in Ontario and really in Canada broadly. And with any invasion, the early stages are really the most important. So we wanted to make sure we got at least some documentation on this, even though it wasn't something we could devote a huge number of resources to. So fortunately, I was able to get the help of Esther Tang, who is an undergraduate research student at the University of Toronto. So she worked with me on her fourth year undergraduate thesis. So a lot of the work from this next section is work that Esther has helped out with as well. The primary research question that we wanted to address in this fall 2021 period, right after we got these observations, was very basically, how common are these things in Southern Ontario right now? Let's just try and get a quick snapshot of, are these just a few scattered sightings, or is it much more common than we thought? And we addressed this with two different project components. The first was to continue to collect community science observations, such as the ones that initially tipped us off to this. And the second was to conduct a more systematic survey of Toronto's ravine system. So I'll give a quick overview of some of the things that we found from this, starting with community science. And I'd like to say on this topic, and this will come back later too, this is really, without this part of people who are experts in their local communities, their gardens, they're attentive, they know what's going on. Without that, we wouldn't have known that this was going on in the first place as well. And so this really helps play a key role in expanding our ability to look at large areas and screen for invasive species and dispersal pathways, which is very difficult if we have sort of a team of one or two. So community science plays a really key role in this story, and I think will continue to going forward as well. So what we did was we took the few photos we had, the little information that we had, put together a little fact sheet and distributed this somewhat haphazardly just to people kind of in our immediate network. It wasn't a major push on this. It was just kind of, let's throw it out there and see what we get. We asked people to provide a photo or a video to help us with a tentative identification and descriptions of the habitat and the timing and so on. So from that, we got about 21 observations, and we were able to get photo or video or specimens from most of these, which was very helpful and great. Most of these were coming from people's gardens, which is sort of what we expect based on how jumping worms move around. Most were in their gardens, but a few were also in public parks. And I think there was one instance as well of people actually finding them in houseplants indoors, sort of crawling around, which I think was a little bit startling for them. A bit of good news was that most of these observations seemed to be relatively recent. So of the people who we talked to, they felt that they were seeing this for the first time that year in 2021. So it seemed like this was relatively new. If we plot those observations on a map here, we can see some patterns jump out. Very much like in that John Reynolds paper that I did with him there, we see these concentrations around Toronto and Hamilton. And a big part of that is just going to be, this is where a lot of people are. This is where a lot of people have their gardens. So it's not necessarily telling us this is the only place that jumping worms are. We just know there are a lot of gardeners here. That's part of it. There are also some outlying observations further out, including close to that original Windsor site. But we can also see these really big gaps in the map. And again, this doesn't mean that there aren't jumping worms there. This just means we don't know what's going on there. So filling those in is going to be an important thing to do in the years to come here. So the second part of this thesis project was to look at this ravine survey. So this came about after visiting one of these community science observations. I'd gone to the house and spoken with the owner there, collected some samples, did find jumping worms, and was about to leave and noticed that their property backs onto one of these ravines that run throughout the city of Toronto. So I decided to go for just a quick little walk, stretch my legs down into the ravine. Was walking around, looked off the side of the path and sort of thought, oh, that doesn't look great. Took a closer look, and there were, of course, jumping worms in that ravine as well, potentially spreading from the gardens of the houses above down into the ravine. So you can see there's a pile of their casts, which is their sort of poop material that they leave on the surface, and several of the worms themselves there. So this inspired us to conduct a sort of systematic survey of some of the Toronto ravines. So as you're probably aware, Toronto is permeated with this network of ravines, which works really well for kind of an experimental setup like this. So we conducted a geographic survey where we sampled 11 sort of semi-random ravines just to check for jumping worms. So we had a survey protocol where we basically walked down the main path and at fixed intervals would check for evidence of jumping worms. And very simply, sort of the big message from this was that we found jumping worms at 4 out of the 11, including the first one, where we spotted them, so about a third of them. And so this was kind of sort of a mixed outcome for us in terms of that one ravine was not a one-off. They are elsewhere, but they're also not everywhere yet. And within those sites, there's a lot of variation. So black dots are where we didn't find jumping worms, yellow dots we did. And some sites had as few as 5% sort of occupancy, and some up to 94%. They were completely inundated with jumping worms. So site to site, there can be a lot of variation as well. And in both of these, you can see just looking from the maps, the proximity of these sites and the trails to the houses and presumably the gardens where they are probably ultimately coming from. So if we were to take what we learned from that first summer and fall, what do we know at that point? The big one, of course, was that jumping worms are present at multiple locations in Ontario. We know we're dealing with at least 4 species. Evidence seems to suggest that they're relatively recent, but also not brand new. We're seeing them mostly in gardens, but also see that they've already spread into some natural or semi-natural areas nearby. And if we kind of look at this across various scales, we see that they are not ubiquitous yet, but they're also not completely rare. It's not just sort of one sighting that's isolated. There are many things that we still need to figure out, and this applies in the US as well, even there where they've had jumping worms for many more decades. There's sort of a surprising dearth of information about this in terms of how are they distributed at large and smaller scales? What are their impacts? Really quantifying what they do to soils, biodiversity, erosion, and so on. We know the gist of it, but sort of getting more specific data is always useful. How they interact with European earthworms is also an interesting question, as we notice at a lot of our plots that you tend to find European earthworms or you get jumping worms and kind of knot the two together. So there's some evidence that they actually displace the non-native earthworms that came before them. And then, of course, how do they actually spread around and how do we try and limit that? So what do we do now? What do you do now? What do I do now? There are lots of things to be doing. And I think a lot of this comes down to which type of worm we are talking about, because these are different situations. So if we think about European non-native earthworms versus jumping worms, in the case of European earthworms, I think this was a lot of my PhD work was looking at that this is a really interesting system because it's an invasion that has been going on since probably the 1500s. They're very abundant. They're widespread. We don't really have any good ways to get rid of them. And honestly, there's a fair case for talking about at what point does a species that is from somewhere else cease to be a non-native invasive species? At what point do we consider them more of a naturalized species? And I'd say we're getting closer to that point with European earthworms. Jumping worms, again, are a very different situation. It's a recent invasion, relatively speaking. They're not that common yet. We also don't have a good way to control them, but we do have some options to slow spread that we'll get to later. So in the case of European earthworms in this situation, the general recommendation I would kind of make here is that we learn to live with them in general. They're kind of here to stay, and that's not going to change. And that's effectively what I did for my master's and PhD over 7 years of grad school is what does that look like from a conservation standpoint? How do we understand what they do to an ecosystem and how do we manage an earthworm invaded system, recognizing that it is unique from a non-invaded system? Just not necessarily that it's worse, just that it's different. A really important part of the story that I want everyone sort of to take home with them, and I don't mean it as sort of a big downer, it's just sort of a fact, is that non-native earthworms of any ilk will and are becoming inevitable and growing parts of the Canadian soil community. This is just how it's going to be. And there are various reasons for this. The big one, of course, is we can't control them. So once they get to a site, we don't have an effective or targeted enough way to get rid of them. It's a below ground invasion, so they're difficult to spot, they're difficult to access. They spread by individuals, but also by cocoons, and those are very difficult to detect, even if you are trying to. So it's easy to miss even just a few, and that's enough. There are way too many vectors of dispersal by which they are introduced to a location and then redistributed within that location. And there's also an economic element to this as well. And sadly, I think we're looking at a case where there are insufficient immediate economic incentives to have policy to regulate non-native earthworms. Non-native earthworms absolutely have economic impacts if we kind of think big picture in terms of what they do to biodiversity, to soil carbon, even to timber production in the north and this sort of thing. But it's a complex relationship that takes many years to develop. It's not as simple as a non-native pest that comes in and threatens corn production or something like that, or softwood lumber. It's not an immediate enough link, so I think it's very doubtful that we're going to see strong policy enacted in a timely fashion. So what do you do with that? If they're here to stay, how do you interact with this new system? And I'm not going to dwell on this part. This is kind of more of kind of that grad work that I did, basically looking at different positive effects of non-native earthworms and negative impacts of non-native earthworms, and how you can kind of integrate those into how you manage an ecosystem. So that would be my general recommendation for European non-natives. With jumping worms, however, I think there's a lot of value in trying to slow the spread of this right now. The first thing that you can do is be aware that they're here now, and now you're aware of that, so you can check that one off. And when we say here, that's where we found them so far, but also potentially many other places. The very fact that this only came to us because someone saw it and chose to report it to someone who is interested in doing something with it means that they could be in many other places and just simply haven't been recording yet. So we have colleagues working in the East Coast who are starting to get sightings out there, and I would strongly suspect that as we start to look elsewhere in the country now and in the years to come, if you look, you're going to probably start to find them. An important aspect of knowing what to look for here is knowing when to look, or knowing what to look for at a specific time. Because of this annual life cycle, there are many times of the year where you can be in a jumping worm invaded area and there's nothing to see because they are cocoons. So through most of the winter into even early spring, you're not really going to see anything because they are cocoons in the soil. Come May and June, so where we are right now, they will have started to hatch. They exist as juveniles in the soil, very small little nondescript earthworms, hard to see, hard to differentiate from non-native European earthworms, and not as impactful to the soil. So they're present, but they're not that obvious. And then as we go into the summer and then on to the early fall, that's when they become mature adults and start to have the most obvious impacts on the soil. And this is one of the frustrations of the system, is that they are most obvious kind of the latest in the year. So early on is when you would want to step in and intervene, but it's also when they are hardest to spot. Fortunately, the worms themselves, when we're looking at adult jumping worms, are relatively distinctive compared to European earthworms. So we'll go over some of those features right now. Overall, they have this relatively smooth, kind of shiny body compared to other European earthworms, and we can sort of see that in this photo here. The adults will also have this clitellum structure, so all adult earthworms have this. It's a reproductive structure involved in manufacturing a cocoon. But on a jumping worm, it's kind of this milky white coloration. It tends to be close to the body rather than sort of projecting further out. And it's ring-like, so it runs all the way around the body relatively undisturbed. On a European earthworm, it tends to sit a little bit more like a saddle, where it's on the top, the sides, and then the bottom kind of flattens out. So that's a major difference there. So if we put these two side by side, you can see that there. So that's one of our dewworm night crawlers, again, sort of our big European earthworm that we have. And you can see that difference in the sort of smooth, shiny body, the coloration, the clitellum, this kind of milky white versus more of an orangey color, and so on. That being said, important to remember that with jumping worms, it's not just adults. When you're looking at certain times of the year, you will also get juveniles or sort of subadults that haven't fully matured. So on the right there, you can see a jumping worm that has yet to really fully develop that clitellum. So they're much smaller and it's much less obvious what you're looking at. So that's a little bit tricky. Fortunately, what's probably most useful for jumping worms is actually their behavior, and it's behavior from which they get their name, which is a sort of jumping. It's really more of a kind of lateral thrashing kind of motion that they do when they're disturbed. I'm going to see if this video plays properly. It's always a little dicey putting videos in, but this is from some folks at the Royal Botanical Gardens who made this sighting and shared this video with me. So big thank you to them for that. So you'll see it's pretty quick, but you're going to see them sort of kick some of this surface soil away and see the characteristic sort of jumping worm motion there. Okay, so again, it was pretty quick, but hopefully everyone sort of saw that there. Once disturbed, it's this kind of twitchy thrashing side to side. Other worms, of course, if disturbed, will kind of move around, but it's not quite as twitchy would be the best way I would sort of describe it. And once you learn to see that, that's a pretty reliable characteristic, fortunately. They will also, as a predator avoidance behavior, some will drop their tail. They'll self-amputate that tail and then try and take off, hoping that'll sort of distract the bird that they think that's trying to eat them. So that can be diagnostic as well. Even if you don't see the worms themselves, you can see indirect evidence of them being there, most notably their cast. So again, that's that poop material that they leave at the surface of the soil. It can sometimes be a layer up to 5 plus, sort of 5-10 centimeters thick. It's very loose. It's very crumbly. I have described it as being like a dry, loose coffee ground that's been spread across the soil surface. And it's very even. So here's a shot of that kind of zoomed out over a larger area. So you can see that stretching into the background there with the plants kind of poking up through that. So if you were to put your hand down into that, you can kind of scoop up just sort of these loose crumbly bits and potentially some jumping worms as well. So that's quite different from what we get from other surface casting European species like the nightcrawler, which make similar looking material, but it tends to be in these little clumps and it's a little smoother and more rounded, and it doesn't accumulate in a thick mat on the ground like this. It's more of these little piles. So the second thing that you can do is know how they spread. And this is an area where we really do need more research. We have some anecdotal ideas about it, but we need more information. At our best guess from sort of historical data right now, we think that worms and cocoons can spread via a number of different dispersal mechanics, including nursery plants. This is a big one that we're looking at right now. We think it's probably how it's getting into these gardens, where it's then showing up and spreading into the ravines and so on. It's probably plants that are coming from the US in areas where there are jumping worms, or you could have direct imports from Asia where the species are native. It's more likely that they're coming in plants that are in a soil-based media, but we're not totally sure about that. But the more soil-like is probably more likely to be infested. Mulched plants, because we think mulch itself can be a major source of material in which the cocoons can be harbored. And as I sort of noted already, more tropical or imported plants are more likely to be infected. Mulch, soil, and compost, other sort of soil amendments, also are potential reservoirs and dispersal pathways, though it very much matters where they're coming from. So if it's kind of a municipal green waste collection and it's coming from somewhere where there aren't a lot of earth jumping worms already, there's probably not much in there. But if it's being imported over a larger distance, then it becomes more of a concern. For materials that need to be heat treated, if they have been treated in excess of 40 degrees Celsius for at least 1 to 3 days or more, that should be sufficient to sterilize it of earthworms and their cocoons. However, that isn't always done. It's not always done properly. And there's also the risk of if a compost pile is just open, jumping worms can leave because they're mobile when it gets too hot and then make their way back in after the heat has been removed. A muddy footwear is one of these dispersal pathways that we talked about before. There's been very little research on this. This is one that we're hoping to do some more research on ourselves, looking at how readily cocoons get stuck in the treads of muddy boots and sort of get carried around. In general, with jumping worms or invasive plants, it's always good sort of practice to be mindful of cleaning your shoes off before you move from area to area, especially if you're hiking around. So finally, do what you can to slow the spread. So we know what to look for, when to look for it, and so on. We get lots of people saying, well, I think I may have jumping worms. This is kind of what it looks like. What should I do? Which is a very valid question. The general advice that I give, and will give again here to borrow from Douglas Adams, would be to not panic, but we throw a little asterisk on there and we say, but to be careful where possible. And it's really this tricky balance that actually Margaret alluded to earlier there, and is really important part of this conversation, is being careful, but not worrying about it excessively. And it is a tricky balance. So remember, we talked about this before for European earthworms, and it is the same for jumping worms. We have jumping worms now, and that's not going to change. In fact, we're going to have more jumping worms in 5 years, 10 years, 50 years. They are a part of the Canadian soil community now, and there's no getting around that for all of these reasons listed here and others. They're just part of our soil fauna now. However, it is still important, and I think recommended by me at least, and others, I think, to limit and slow the spread where possible. I think there is value in this. So slowing the spread of invasion is important because even if they're going to get there eventually, it reduces the cumulative stressors on our ecosystem. So if we think about areas near human habitation in particular, or really anywhere, they're already dealing with quite a lot in terms of climate change, fragmentation, other invasive species. And each new stress that gets piled on can reduce the likelihood of native biodiversity making through that intact. So slowing down additional stressors is very useful. A more gradual invasion can allow time for adaptation. So species can produce resistance in various forms to invasion. New species can learn that this is something that they can eat. There can be new pests, there can be new predators, but those interactions take time to develop. Those are those novel interactions that we talked about before. So giving those more time to develop is useful rather than having everything come in all at once and sort of pile on and lead to the local extinction of species even, or just loss of local biodiversity. So giving it as much time to adapt as possible is useful. So, broadly, to slow the spread, keep an eye open for jumping worms and their casts in gardens, natural areas nearby, potted plants, any horticultural material that is purchased, keeping in mind what you can expect to see at different times of the year. And if you do find suspected jumping worms, it's really important for us to find out and to have sort of a centralized record of where they are occurring. So the main tool that we are doing for this is a system called EDMAPS. This is the Early Detection and Distribution Mapping System. It's an online system, and the link is provided here. What you need are photos or videos, and then you can sign in. There is a login, but it's very simple and it's a free system. You enter some information about where it was found, the photo. Those photos get sent to sort of experts who will validate them and sort of confirm whether this is what people think it is. I'm one of the people for the Jumping Worm Project, so those would potentially come to me. And then we have a record of it in a database that is then accessible to the public and that is also accessible to researchers to extract data and sort of do experimental work with that as well. So this is the main place that we are trying to direct people right now. If you think that they're there, report it. And then try to not spread it around. So avoid redistributing infested material to other locations. So this might be if you think you have jumping worms in a specific area, avoiding sharing plants from that location to elsewhere. Certainly don't dump soil into a ravine, for example. That's good practice in general, but certainly don't do it in this case. If you have a very small volume of infested material, so it came in a pot, you think it's still in the pot, or it's a new bed that you put in or something like that, heat is sort of the best tool that we have so far. So small volumes of soil or mulch can be solarized. So bagging it up, placing it out in the sun for at least 3 days, trying to get that above 40 degrees should be effective at killing whatever's in there. And then that can be disposed of or used depending on what the material is. The problem is that this becomes impractical when we're talking about larger volumes or larger areas. But if it's small, this can be an effective option. If you're looking for more information on this, one of the most comprehensive Canadian resources right now would be the species profile at the Invasive Species Centre, which we helped contribute to and will be updating as we get new information as well. It has up-to-date information and links to several other academic articles and news reports and things like that that you can check out. And finally, stay tuned for a community science project that we will be running in the late summer, early fall of this year. So we're very fortunate to have got a small micro grant from the Invasive Species Centre for Ontario to help fund a little bit of this work. Essentially, what we're going to be doing is a combination of outreach and community science monitoring, where we will be reaching out to members of different organizations, such as your own, but also the Master Gardeners of Ontario, the Toronto Nature Stewards, and others. We will be providing informational webinars such as this one, but a little bit more focused on identification. Hopefully, if people are local, we'll be providing some guided hikes as well, so we can see what some of this looks like on the ground. And then we will be sending people back to wherever they came from to conduct screening in their own garden or parks or areas nearby so that they can check using this information that they now have, whether they have jumping worms or if they don't, and then to take that information to EDMAPS and file a report. We will then take all the information on EDMAPS and then process that to get a better picture of how widespread this is, where they're moving, where the hotspots are, and the like. So that will be something that we provided to members sort of in an email that's coming later in the summer if you're interested in participating in that as an individual. That would be immensely helpful to us, and it's kind of our best option right now for getting kind of a big picture sense of what's going on. And so on that note, it's a really big thank you to all the people who have been involved in this so far. People have been tremendously interested in this and really engaged in the topic. And like I said, we wouldn't be able to get these data or even know that people were here in the first place, or that these jumping worms were here in the first place without the assistance of people who are interested like this. So I really appreciate that. And thank you very much. And I think we can have time